Hi, this is Kenneth Wong, Senior Editor for DE 24/7. Will 3D printing replace subtractive manufacturing? This is one of the questions I and other panelists tackle in the recently broadcasted DE Hot Seat webcast. So let's hear some excerpts from our discussion.
We aren't going to see our version of Metal AM replace manufacturing or subtractive manufacturing anytime soon. With what we do, machining is the perfect complement to printing a part that's otherwise unmakeable, unmanufacturable, and then machining takes us to the finish line. Without it, we would be lost in most cases where, we need threads cut on a part, we need sealing surfaces and a machine surface. We need this, and without it, we wouldn't have a useful part. And what we're doing as a company is really enabling a new design space for engineers and designers to make new parts and new products. So really, we are bolstering the subtractive market by adding these new applications and opportunities that can be, ways to use subtractive manufacturing that weren't possible before. So it's a great complement and absolutely necessary for what we're doing, and it's going to be for a long time.
Let's talk about some of the strengths and weaknesses, right? With additive, one of the strengths is speed, throughput. You don't have the tooling lead times that you would have with subtractive. So you can shave off weeks, months from a product line, right? For example. One of the strengths that you have with subtractive is you can get tight tolerances, right? You can get very accurate parts. If you put that together, for example, Anthony brought up the, like a mold design. Some parts need deep pockets cut out. And additive, you don't pay for the removal of that pocket. You don't have to have a tooling doing the removal of that pocket. You can have an additive part created. You're only using the material you need. And when you need those fine surfaces, you need those high precision tolerances, right? You can then take that part and move it over to your CNC machine, and you can finish it. That's a perfect example of how the two technologies complement each other.
Yeah, it's interesting because for most of us, CNC machining or machining started to evolve before we were born. Most of us have been around long enough to see additive grow in front of us. And so I think for the first 2 decades, there weren't that many people materialized as the one company that was really out front as the technology was evolving around additive. You had a combination of the processes evolving, the equipment, the printers, the 3D printers and post-processing equipment evolving, and the materials all evolving at different paces. And as those technologies and the science behind the materials started to mature, everybody looked around and said, "Oh my God, the technology has outpaced the software. The hardware has outpaced the capabilities of the software."
You have to be educated. You have to know what will actually print. And that's education that, Velo would help our customers with that, so that when you are receiving a model, a design that an engineer has created, you need to look at it and say, I can print this overhang, but I can't print this one. I need to put support on this. And there are design considerations that you really need to take into account. You can't just put it in a virtual space, click print, and hope for the best. That's not realistic in the world of engineering in general. And it's not an additive manufacturing thing. We have to take these considerations into account when we're designing for the application and for the manufacturability of our parts and our components. So no, it's not easy, but it is a learnable skill, and it doesn't take rocket surgery to figure it out.
So I think when we look at CAD today, it was built really for subtractive, right? When you think about it, it was built 30, 40 years ago for subtractive. The features were built as you would machine the part. That's why you have features that are like cuts, rounds, holes, shells. You built the model, 3D model, as you you would believe that you would do it. So the features are aligned for subtractive. So I think that could morph. Generative, I think, is limited in mainstream because you can't produce it in mass quantities. And then the last thing I would say that needs to change or extend a little bit more is the use of mesh-based files. So in additive, lots of STL files are used, right? They're swapped here and there, not BREP, not the solid bodies. And sometimes it can be hard to manipulate those. And Anthony mentioned a lot of great software products that can do that, but the CAD products aren't some of those products that can easily work with that mesh stuff.
As far as the proliferation of STL, I mean, STL was created for additive in the very beginning. That's why we have STLs. I don't think we can get rid of STLs fast enough. I know I belong to a growing majority of people in the industry that would love to get rid of STLs. More and more printer companies, HP, for example, they started out with what they call their 4200 series MJF print system, and now they're into their 5200 series print system. In the 5200, you actually send a 3MF file in, which actually is mesh-based rather than slices, and we'll call it the first generation or first iteration of the printers. I know other companies are starting to take a look at importing directly in those models. It doesn't make it, as easy as the easy button, like Gene said. There still is no easy button, but that's one step towards it. Taking it the next step is the OEMs actually supporting the ability to be able to print B-reps.
For the full episode, please visit our homepage, select the webcast lined up page, then select Reconciling Additive and Subtractive. Until next time, thanks for checking this out. This is Kenneth Wong for DE.